Kanishka, you can start.
Yes, sir.
Start Namaste.
Greetings to everyone. I'm very honored to be here today, and as well as it's my pleasure to welcome you all on behalf of Chennai Institute of Technology, who has prepped all of us for the Knowledge 4.0, the webinar series. Yes, I'm Kanishka, doing my BE in Electronics and Communication. Encouragement and excellency are the major aspect of our college, and this, as the objective, our beloved chairman, Mr. P. Sriram, has come up with this innovative idea, the online webinar series, which is being really a trendsetter. I'd like to welcome and thank our department to organize this webinar, and I request our organizing secretary, Dr. Dhanagopal, Associate Professor in Electronics and Communication Department, to welcome the gathering. Please, sir.
Thank you. Good morning to all present here. I'm very happy to welcome you all. Hope they are only online FDP-Recent in Electronics and Communication Engineering under Knowledge 4.0 webinar series. This is one of the trendsetting and innovative initiative of Chennai Institute of Technology. It established in the year 2010. Within short span of time, we achieved top 10 among 500 plus engineering colleges affiliated to Anna University Chennai. Knowledge 4.0 webinar series going in a successful manner under the guidance of our Honorable Chairman, Mr. P. Sriram, the first member, a well-known industrialist, and the Managing Director of MD Group of Companies. We have been conducting various webinars under this webinar series, such as technical, research, innovation, and career guidance. In addition to this, webinars. Yes, we have been also conducting FDPs, workshops, conferences, and seminars. So I heartily welcome our today's expert, Dr. Nagarajan sir, Professor, Pondicherry Engineering College, Pondicherry, on behalf of the Chennai Institute of Technology. Welcome you, sir. I welcome all of you once again, the participants from all over India to the webinar. Hope and that you will have a great time ahead. I will call upon Anishka to introduce the chief guest.
Thank you so much, sir. Social media has helped us stay connected to our friends and family moreover than since the spread of COVID-19. With this good essence of social media, this webinar has come. So today's session is all about research direction in wireless network. To present on this topic, we have an expert today. I have the pleasure of welcoming and introducing to you the expert of this webinar, Dr. G. Nagarajan. Welcome you, sir. Dr. G. Nagarajan has acquired PhD in Electronics and Communication Engineering from Pondicherry University, M.Tech in Electronics and Communication from Pondicherry University, B. in Electronics and Communication Engineering from Madurai Kamarajan University. He has 29 years of experience in teaching. He has published more than 40 national and international journals. Also, he attended more than 100 international and national conferences. He has made many significant contributions to teaching field. At present, he is an associate professor, Department of Electronics and Communication, University of Pondicherry. He also was a senior IT engineer. Thank you so much for lending your precious time, sir. Now let's turn the time over to the session. So without further delay, let's get started. Sir, now it's your time. Please proceed.
Thank you, Kanishka, for
You're welcome.
introducing me.
You're welcome, sir.
Very good morning to everyone present here. Uh, my dear friends, it's my immense pleasure to join with you in this wonderful morning. I have two questions with you. Whether you are able to hear my voice? Please
Yes,
say
sir.
yes. Okay. Are you able to see me in the screen? See me in the screen?
Yes, sir, yeah, fine.
Okay. Double happy. Um, Actually, I have given more than 100 talks so far, but this is the first time the opportunity I got to give in the webinar. It's very nice. I remember a saying, either Muhammad should go to mountain or mountain should go to Muhammad. Now, at normal time, definitely Mohammed will go to mountain, but this is COVID time. So now the Chennai Institute of Technology brought the mountain to the Mohammed. I feel extremely happy to meet all of you this occasion. The intention behind this lecture is to give an introduction to wireless communication and wireless networks. Actually, frankly speaking, nowadays wireless communication cannot be said as part of communication because everybody in the society has mobile. So almost it is common to entire mankind not belonging to a single department. I think it become the one of the primary needs of human being. Usually in the primary needs, in that list, it will come as air, water, shelter, food like that. But mobile also one of the essential needs of the human being. Without mobile, it is very difficult for every one of us to spend even one day or one morning or whatever. Are you able to? Is my voice is okay? Is my
Okay,
voice
sir.
okay? Okay. Shall I continue?
Yeah, fine. Yes, sir.
Okay. See my second slide. Uh, are you able to see a proverb in the a saying in the my slide? I read
Excuse
the
me,
pro.
sir.
Yeah.
Sir, sir. Kindly share the slides, sir.
Slides are not shared.
Yes, sir.
Slides are not shared. So just wait.
Yes.
Wait a minute. Wait a minute.
Sure, sir, sure, sir.
Are you able to see slides now?
Yes, sir. Fine, sir.
Now, are you able to see the slide which is saying?
Yeah, yeah. Yes, sir. Yes, yes.
This will be my usual slide, first slide of my presentation. The most profound technologies are those that disappear. They weave themselves into the fabric of everyday life until they are indistinguishable from it. This is a saying given by late Mark Weiser, who is considered as the father of ubiquitous computing and chief technologist of Xerox PARC. Usually, I remember a wonderful story. A US tourist came to India. The purpose of the visit is to see the tourist places near New Delhi. By default, the US tourist approached a tourist company. They have appointed him a driver come guide. A single person is able to drive the car, as well as that he is well known to the places nearest to New Delhi. So they appointed a guide come driver. By default, they went to Taj Mahal first, because Taj Mahal is one of the seven wonders. So the US tourist, on seeing the Taj Mahal, uh, he became amazed. Wonderful thing, great thing. The building looks very beautiful, very marble structure, very white. You are saying it has been constructed hundreds of years before, but still it is good. He asked so many questions regarding the Taj Mahal. Finally, he has given a comment. The king, Shah Jahan, took how many years to complete this building? Now, our driver come guide and said, sir, he took 20 years. Then the US man said, 20 years is too bad, too high. If it is America, you could have constructed within 5 years. 20 years too long. Your Indians are very lazy, very, very lazy. I cannot bear it. Being a tourist, we should not give the wrong comment, the wrong reply, so that the guide come driver was keeping quiet. Then they went to the second building, which is Red Fort. Once again, seeing the Red Fort, the US tourist felt very happy. Red Fort, as the name says, it is red in color, very rigid, very beautiful, everything. Then finally, he asked the same question. The king took how many years to complete this? He answered 10. So 10 years too long. Your Indians are very lazy. If it is America, we could have constructed with 2.5 years. That is sufficient. You are very lazy. Like that, he replied. Then the third place they went, Qutub Minar. Seeing the Qutub Minar, once again the US tourist amazed. So Minar means a tall tower. This is very nice, superb, excellent. I feel very happy. Then he asked the question, the same question to the driver come guide. The king took how many years from that? But our driver is a very intelligent fellow. He's like a student of Chennai Institute of Technology. He definitely know whatever answer he give. Definitely the US man will divide it by 4 and curse Indians, hail Americans. So very intelligently he replied, "Sir, yesterday night I came, nothing was here. Actually, I don't know what it is. When they constructed like that, nothing was available yesterday." Whether this is applicable to the story or not, it is applicable to the technology, especially the wireless communication. Before understanding one technology, other technology comes. So still the textbooks are talking about the 2.5 and 2.5G and 3G. Now we are enjoying the 4G, expecting the 5G. So the innovation rate is very high. It is every day a new protocol comes. Before understanding another protocol, the newer technology comes. That is the situation of the wireless communication. So, um, are you able to see the slide? Hello?
Yes, sir. Yes,
Any
sir.
one of you tell what is the title of the slide?
Need for wireless.
So need for the wireless, everybody knows. You are completely free from the wires. So anywhere you can move, even somebody is while driving the car, driving the bike, they are speaking. It is very dangerous. But anyway, it is possible only because the mobile is completely free from the wire. So earlier, before some 15 or 20 years, only with the landline you can communicate. So it gives a lot of comfortability to the mankind. Not only that, you consider the country like India. It is very large. It is a continent. You cannot see a small country. It is like a continent, so that we used to call it a subcontinent. It contains deserts, forests, hilly uh, areas which man cannot access very easily. So, in that situation, in that terrain conditions of drastic change, definitely the wireless is a very great gift. Without wire, we can do so. Wherever we go, we can enable the wireless connectivity by providing that. So definitely the wireless and mobile communication is a great boon, great help to the mankind. The slide number 4 shows the historical incident when Alexander Graham Bell first tested his telephonic conversation with his co-researcher Charles Sumner. So the evolution of wireless take a lot of steps, a lot of contributions helped for the evolution of wireless, the mobile which we are using today. It includes Maxwell, uh, Faraday, Hertz, contributions of David Hughes, Edison, Jagdish Chandra Bose, Nikola Tesla, and more. So, generally, what is the wireless communication? How is it possible? Just to see the slide, you can see the red and the blue combination of the fields. Any electromagnetic signal consists of two fields, namely electric field and magnetic field. In the diagram, you can see electric field, which is red in color, magnetic field, blue in color. The condition is the electric and magnetic fields should be perpendicular to each other and also perpendicular to the direction of the propagation. So in the y-axis we have the electric field, the x-axis you have the magnetic field, and the z direction gives the propagation direction. It is continuously going. So any signal, whether it is voice signal or data signal, whatever you want to call it as electromagnetic signal, definitely will consist of this. So it will be traveling throughout the universe in all the directions from the Earth. This is a common rule for an electromagnetic signal is concerned. So in the all wireless communications, we follow the electromagnetic propagation like this. Meanwhile, is it okay? My voice, picture, slides, all are okay?
Yeah, okay, sir. Okay, sir.
Okay. So the wireless channel, it is very difficult to handle the signal because of many reasons. Attenuation comes, absorption comes, interference comes, and diffraction comes. So many, usually in the picture, you have one hero, one heroine, one villain. But in the wireless cinema, you have so many villains. In that very, one of the very greatest villain is fading. Fading means you have a signal, certain portion of the signal will be faded. Faded means the signal strength will be reduced compared to the other portion of the signal, like the common life. We have our shirt is faded, pant is faded, only this portion of the churidar is faded, like that. So if fading is uniform, that is okay, but if it is non-uniform, only at a particular portion we have the weak, we don't feel good to wear it, we will throw it away. So the same thing occurs, we can, two types of fading, namely large scale fading, small scale fading. So you see, we have the signal and you have the blue color horizontal line, which is the threshold. Up to the threshold, greater than the threshold, no problem. It is applicable, it is okay. The signal is having sufficient strength. But some portion of the signal is in the orange color now. So the signal which is below the threshold is not desirable. So fading occurs for the region which is lesser than the threshold. So non-fade region is greater than the threshold. This fading may be small scale or large scale. For example, in the slide number 10, you have two types of pictures. First picture is large scale fading. So you have a center path, blue color, and you have reflected paths, red color as well as green color. So all three rays are starting from the same source, reaching at the same destination, but they take a different path. So that the fading occurs here. As the time duration is different for everything, we call it as large scale fading. You see the second diagram in which the variations are very, very small. The time is the x-axis, so this we call as small scale fading. Why fading occurs? Fading occurs due to the multipath propagation. Suppose this is our base station. From that, the signal directly there has to go, but it won't go directly. There may be some local scatterers. The mountains which are surrounding us may distract the propagation rate, and the tall buildings present in that will also affect the signal. The local scatterer, co-channels present, all will affect this one. So summarizing, the local scattering provides you the fading. Multipath propagation yields intersymbol interference. Mobile motion is because of the time varying channel, and cellular spectrum reuse provides co-channel interference. Usually we have a hexagonal model. The geographical area has been split into hexagon. So this will be a complete one unit. So say 1, 2, 3, 4, 5, 6, 7. All are having uniform area in nature. Each will be given a particular frequency for use. So all 7 will be one unit. This is second unit. This is third unit, 4 unit, 5 unit like that. So in one unit, we have 7 cell sites. Cell site 1, cell site 2, 3, 4, 5, 6, 7. Each cell site will have one carrier frequency. One carrier frequency completely dedicated to that particular area is concerned. So if you take this one unit, each will have one single frequency, and in the second unit, same frequencies will be used. For example, here yellow uses 5 megahertz as the carrier. Then this yellow will also use 5 megahertz. This yellow will also use 5 megahertz. This we call it as frequency reuse. We have advantage in frequency reuse because the number of frequency required will be very less. But the disadvantage is because of this frequency reuse, we have the 4-channel interference. Even though we say it is hexagonal in nature, practically it is nothing but a circular. So from one cell site, the vehicle moves to other cell site, means automatically the frequency changes. Suppose while within this blue color area, you have frequency of 1. Then while moving the boundary from the blue color, automatically the frequency will be different, F2. So while moving the signal, without affecting the data, the carrier frequency will be changed. That we call it as frequency handoff. So the frequency reuse, frequency handoff, both are very important aspects in the mobile communication is concerned. Modulation is very important. Electronics communication students will know. Even electrical will also read one paper on communication. So modulation is what? Most of the signals, 99% of the signals are low frequency in nature. If you take audio frequency, the range is 20 Hz to 20 kHz. The maximum frequency itself is 20 kHz. Even you raise your tone, only decibel level will increase. Frequency cannot change. So whatever frequency a human being talking, hearing, all will be belonging to 20 Hz to 20 kHz. These smaller frequencies will not travel for a longer distance because they won't have that much capability. So for carrying one information from one place to another place, a carrier is like we want to send a letter to Chennai. What we do? We write the letter, and the envelope is the carrier. The purpose of the envelope is to save the information. As soon as the destination is reached, the envelope will be removed, and the information which we kept inside the envelope will be taken away. So in the same process, a carrier is introduced in the modulation. Modulation is the process of adding a carrier with the information. There are 3 types of modulation: amplitude modulation, frequency modulation, phase modulation. in the analog domain. In the digital domain, we have equivalent values like equivalent methods called amplitude shift keying, frequency shift keying, phase shift keying. Which methodology is better? Which modulation is better? If you ask, that depends upon the application which we do. For example, the HDTV will be preferred with the 8 VSP. For remote sensor network, BFSK has been preferred. And for CDMA thing, QPSK we prefer. So depends upon the requirement. Suitable modulation technique can be used because each modulation technique has its own advantage, disadvantage. Keeping the advantage of it, we can say. So even we say the digital communication, you will be feeling that the signal which are analog in nature. So the analog signal will be coded into 1 and 0s and will be sent from the computer to computer or desktop to desktop through the modulator and demodulator. So we have many methodologies for communication. The many types of communication. So in this picture, you can see the satellite communication. Satellite is well above the earth, located well above the earth, approximately 36,000 kilometers well above the earth. You can ask, why this 36,000 kilometers in particular? Why not 30,000 kilometers, 25,000 kilometers, 40,000 kilometers? Why are you fond of 36,000 kilometers? The reason is, now Earth is rotating. Earth is continuously rotating. For all 24 hours, it is rotating. Even at the night, we are sleeping, but the Earth won't sleep. And even Sunday, it is working. So 24/7, it is rotating, self-rotating, and also rotating the sun. Therefore, if Earth is moving, then the repeated station, which you are placing well above the Earth, should also move. Because Earth is moving, definitely the satellite which you are launching to trace the Earth should also move. So, for completing one revolution, the Earth takes 24 hours, one day. So, if satellite also has the same time period, then automatically the satellite will synchronize with the Earth. Therefore, even satellite is moving, Earth is moving, both take same time of rotating completing one revolution. Therefore, it will be stationary. So that we call it as geostationary satellite. That means satellite is not stationary, it is moving. But compared to Earth, it will be stationary because the Earth speed and your satellite speed are synchronized. Therefore, with respect to the Earth, the satellite is stationary even though it is moving. So this is possible in the case of 36,000 kilometers for geosynchronous or geostationary satellite. Suppose you want lesser area. Actually, with 36,000 kilometers, 3 satellite is capable of controlling the entire globe. Suppose you are not interested in covering more area, then automatically the satellite can be located well below 36,000. So we have LEO, low Earth orbits, MEO, medium Earth orbit, like that. So this diagram, slide number 21, gives the paradigm shift from 1G to beyond 3G. 1G has 1G was analog in nature, circuit switched, basic voice telephony alone it had. In the second generation, it becomes digital. Along with the voice, data also operated. So packet switching has been adopted. Usually the 1G only circuit switching, here packet switching also. The 3G, all are possible. Global coverage, global roaming is there. Now are in 4G. So all IP network, later we are going to discuss with a lot of feasibilities, flexible platform, high-speed data, with the quality of service, global coverage, global roaming, we are able to see. Many organizations are doing this paradigm shift in a very wonderful way. OFDR is the technology used in the 3G, which is usually the biggest problem in communication is adjacent channel interference. While you operate with channel N, the N-1 and N+1 will give interference. OFDM avoids them because even if you have many adjacent channels, At one time, only one tone will be operating. Other tones will be phase shifted. They will be available, but they won't be available this phase. It will be shifted with a 90 degree or 180 degree, 270 degree, so that they are nullified. So in this angle, only C will be alone. A, B, D, E will be nullified, shifted, phase shifted. So OFDM is orthogonal frequency division multiplication. Very much helpful. So one of the issues of wireless communication is we have to provide security. The information which you are sending should be very safe. It is called information security, proper encryption and decryption of the data. The network we are working, that network should be secure. So with suitable firewalls, we can save the network. So network security, information security, we have system security. The laptop or machine, the intelligent device which you are using should be secure. So password will be suitable where this one. So this is a brief introduction about the wireless communication. The second part talks about the wireless network. What is a wireless network or what is a network? A network, usually in the communication, we have point to point, one source, one receiver. In communication, three essential elements are there: sender, receiver, medium. In wireless communication, medium is wireless. So sender and receiver again. This we call it as point to point communication. And there is no strict rule that only one receiver should be there. For example, now I am speaking only one sender, but 250 participants are attending this knowledge 40. I was told. So 400 receiver. In that situation, this is a network. This is not a point-to-point communication. This is a network. So network have more than two elements. All have interpossibility. Now anybody can interact with me. So like that, any device can access with other device. This is called network. If all these networks are connected without wires, then it is called wireless networks. Different wireless networks we are going to see. Wi-Fi, you are well exposed to Wi-Fi. Whenever you go to a hotel or restaurant or mall, it is Wi-Fi enabled. That means what? You have internet connectivity without wire. Even if you have the device, you know the password, automatically it will be getting connected everything. One of the problems of Wi-Fi is a limited area. It will be operating only with 50 meters. Even with the booster, it cannot go beyond 100 or 150 or 200 meters. And the data rate may not be sufficient at some time. So to overcome this problem, we go for WiMAX. WiMAX in this area is improved. Area is increased. So the Wi-Fi we have some 100 meter or 200 meter. WiMAX you can go in terms of kilometer, 20 kilometer, 30 kilometer, 40 kilometer, like that. So even the entire city you can have the WiMAX this one. The IEEE 802.16 is that standard for WiMAX, and you have the plug-in methodology. Whenever you want the WiMAX, if the enabling device is available, then the particular area will be illuminated to that one. So that interoperability, plug and play products are available. If that Wi-Fi would succeed in every geographical market, which we want. Another one, Bluetooth technology, one of that. It is a personal area network, PAN. So PAN means within a room, within a hall. The definition for room hall means if any obstacle is coming in between, a wall is coming, it won't work. So Bluetooth technology is a personal area network. It works very well. But the problem is limitation of the data rate and the space. Even if you want to transfer the data from one mobile to another mobile with Bluetooth, both should be kept very near, then only it will work. So the accessibility will work only in the line of sight or very closer. That is one of the drawbacks. Second, the data rates are very, very less. So even though the technology says it will work for 10 meters, but practically when we keep both the mobiles side by side, then only it will work. The better band technology is ultra wideband communication, UWB. We call it ultra wideband. So this will be a better one compared to the Bluetooth technology. Both the Bluetooth technology and ultra wideband are personal area networks. They will work within a room, within a hall. Even hall may be very greater, no problem. But but there should not be obstacle, there should not be wall anything. So you have in the big hall, you have some 50 devices. Without wire, it will work. It will be enabled. So with the ultra wideband, with the Bluetooth only, you have to keep both nearer. But in the ultra wideband, it is no problem. Excellent bandwidth it has. It is operating 1 to 10 Gbps. So very high range of short range is achieved. And the system is very simple, low complexity and low cost equipment we have. The power transmitted is in the milliwatts, very limited power, so it is not injurious to the biological system. And the multi-path interference immunity it has, therefore completely free from the interference. High penetration capability it provides. Accurate positioning can be achieved by this one. So in any way, definitely it is a better technique. UWB is a better technique than the Bluetooth technology. So with the Bluetooth technology, single touch, you are transferring a song of your favorite movie from mobile A to mobile B means with UWB, as it is operating in the Gbps, with the single touch, you can transfer the entire movie from one mobile to another mobile, as it provides excellent data rate of up to 10 Gbps. So the IEEE standardization are 802.15.3a and .4a. You can see a diagram here. Um, my dear friends, are you able to hear me?
Yes, sir.
In the x-axis, we have PAN, LAN, WAN, WAN. PAN means personal area network, local area network next to LAN. So personal area network is just a room or hall. Local area network is bigger area in few kilometers. Like metropolitan area network, MAN is up to some 50 kilometer, 40 kilometer like that. Then WAN, internet is a WAN. So beyond 30 kilometer is WAN. These are all given in the x-axis. And y-axis talks about the approximate bandwidth or data rate. 1 Mbps, 10 Mbps, 100 Mbps, 1 Gbps like that. So in that, the different standards, the networks have been given. For example, the band you can see the Bluetooth is at the bottom and ultra wideband is above. Then Wi-Fi is given in the LAN and WiMAX 802.16 is indicated in the MAN. So my dear friends, from this diagram, what is your general observation? Anything you observe from this one? What is your interference? What is your inference from this diagram? Any inference from this diagram? I will say one of the findings. The x-axis says the distance, PAN up to 10 meter, LAN up to 100 meter, WAN up to 50 meter, WAN beyond 50 meter. When the geographical area becomes more, data rate is reduced. Are you able to see? The PAN uses very high data rate, where the WAN uses very lower data rate. So if geographical area is more, becoming more, then automatically the available data rate will be very much reduced. That is one of the observations we can make. Another network is called cognitive radio evolution, cognitive radio. So normal radio we know, which is found by Marconi. Software different radio in which it is the radio is tunable and with software itself. There anything you want to tune with software and it becomes flexible. Cognitive radio is an intelligent device. What it do is you have the frequency spectrum. All the frequency spectrum is not utilized fully everywhere. The normal day around 11 a.m. in the morning, if you are making phone call means you will receive busy tone. That means network is not free. Evening around 6 o'clock you are making call means everybody calls so busy hour. But at the midnight if you call at 1 o'clock, at 2 o'clock, definitely it will be free. So what is the meaning? The spectrum is available for all 24 hours. And sometimes it will be busy, sometimes it will be idle. So what your cognitive radio finds, it finds the free space, free spectrum, unused spectrum at each and every instant is available. One of the biggest problem in the wireless communication is Demand is more, availability is less. Our aspirations are more, but availability is less. So the cognitive radio, it says what is the available spectrum. Any unused spectrum is available. That we call it a spectrum force. The spectrum force have been identified, and that will be used for the communication. That is the purpose of the cognitive radio. So the intended users, the normal users, are primary users who are tall in color. In between the primary users, we have the gap. So that unused spectrums are used for cognitive radio users that we call as secondary users. So the unused spectrum between the primary callers, primary users or licensed users are identified, and that will be used for the communication as per our requirement. So we have the standard rural area network of IEEE 802.22 and the next network called ad hoc network. The ad hoc name itself says it is a temporary. The literal meaning of ad hoc is temporary. So we have a lot of situations where we get natural calamity. Some flooding occurs, some earthquake occurs, so tsunami occurred. So in that situation, definitely at the time of the calamity, the number of calls originated in that area will be very plenty, hundreds, thousands, lakhs of calls. So temporary network will be available. After 1 or 2 days, the requirement will be very less. After 1 month, you have to forget that. After 1 year, nobody will do that. So in order to tackle that particular situation, we can make a temporary network. That network is called ad hoc network. So for any network, nodes and server required. Server guides everyone, that is acting as the mainstream for everyone. So number of nodes get connected. So the nodes will be there, servers will be there. They are self-configurable. There is no clear-cut configuration like that. You have to connect a bus network, mesh network, not like that. Depending upon the situation, any network, any configuration you can make. So they are self-configurable. Even if you are configured in one way, that will not be a constant one throughout the one. It will be, it may be changed with respect to the requirement. So in an ad hoc network, number of nodes are available, server available. If both are, the nodes and server are mobile in nature, then it is called MANET, mobile ad hoc network, which is one of the emerging areas in the communication. Then you have another network called the wireless sensor network, in which each node will be a sensor. Sensor is a sensor consists a transduction element. So a transducer will convert non-electrical quantity into electrical quantity. So it converts pressure into electricity, temperature into electricity, humidity into electricity, everything. Always the non-electric quantities are converted into electrical domain. In electrical domain, we are very comfortable. If signal is weak, with amplifier, you can amplify. If signal is too strong, with attenuator, you can reduce. If signal consists of loss, with equalizer, you can make. We have ammeter to measure current. We have voltmeter to measure voltage. We have mega to measure the power. So any measurement of your desire can be carried out in the electrical domain. So in wireless sensor, number of nodes will be available and the server will be there. So each node consists of an intelligent device and the transduction element. The transduction element converts non-electrical quantity into electrical quantity. So where we can employ the wireless sensor network, anywhere you can apply. Now it is very hot. Therefore, to know the normal temperature of Chennai, million sensors can be waved from helicopter to all different parts of the Chennai. They will be continuously sending data to the server. So from that you can say what is the average temperature of 11th June, or the exact temperature at 11 a.m. of 11th June, or highest temperature of 11th June, whatever it may be, whatever the user desire, that can be obtained from the data available in the server. Wireless LAN, it is one of the biggest boon in the wireless arena. Usually LAN will be connected with wire, this is wireless. So with a few kilometers in nature, you have the LAN connected with the number of positions as per your requirement. We have different standards here, 802.A, B, G, E, I. if you ask which standard is good, which methodology is good, that depends upon the requirement. Each network has its own advantage. For example, 802.11i provides encryption. So security is your option, then you control that one. If you are very much particular about quality of service, you can go for 802.11. If you are very much particular about the adjacent channel interference, so 802.11a preferred because OFDM reduces the adjacent channel interference. So as per the requirement, you can choose any one standard listed in this list. The list is not complete. Still, so many standards are available. Just for example, I have shown here some 5 or 6 standards. And many input, many output, space-time coding is one of the emerging areas of wireless communication. So we have usually antenna is used at transmitter and receiver. Antenna converts electrical signal into electromagnetic radiation or vice versa. Therefore, the antenna used in the transmitter in order to convert electrical signal into electromagnetic radiation. The same way, the antenna will be used at the receiver to convert electromagnetic radiation into electrical signal. Now, in the biggest problem of wireless channel is attenuation comes, absorption comes, scattering comes, fading comes, adjacent channel fading is there, co-channel fading is there, diffraction is there, interference is there. So, it lacks reliability. The wireless communication lacks reliability. Therefore, instead of using one antenna, you can use number of antennas. For example, in this diagram, 5 transmitter antenna used, 5 receiver antenna used. So the same signal is sent by the different antenna. Therefore, as you are sending 5 signals, at least one signal will be better. Even attenuation is affecting some signal, absorption affecting some signal, interference affecting signal. So above 5, at least anyone will be good. So that better signal is received and recovered from the receiver. This is the concept of the MIMO, which is coming in a very big way. Green computing. Usually, you could have seen the Rajinikanth Yendiran 2.0 movie. So you know the problem of radiation from the cell radiating tower. Everyone who provides the connectivity, wireless connectivity, is radiating with very high power. That movie was talking about the demise of birds. Yes, definitely. Not only the birds, the higher radiation will affect all biological systems available, including human beings. Therefore, basically, why do you provide more radiative energy? Because to increase the coverage area. Increasing coverage area is good, but it is injurious to human being and biological system. Therefore, instead of radiating more power, radiate less power. Tower height should be reduced. Radiating power should be reduced. Economically, it may not be viable. It may require more cost. No problem. The human life and other life, other other species life are more precious than money. Therefore, to make environment friendly, lower energy will be transmitted with less radiating tower, which has been practiced in the Auroville near to Pondicherry. And you have another network called ubiquitous computing, in which the devices are connected with IoT enabling. Therefore, they are very user based, and the future trend is expected as ubiquitous computing everywhere. So the normal device will have the internet connectivity, IoT based characteristics, that is the ubiquitous computing. Cloud computing is one of the emerging areas in computer science. So usually the problem with the computer networks will be the resources are very costly. Instead of investing more money in the cloud computing, instead of investing more money in the normal computer systems, computer networks, the cloud computing clouds are available. So the clouds has costly resources. Either it may be software or hardware or a combination of these. So by paying a small incentive, a small money as a rent, you can avail that service. So cloud computing is coming in a very big way. Nanotechnology talks about the tiny size of particle which is used for fabricating the devices, which are providing amazing performance, innumerable applications it can be used, and very effective in wireless communication. Embedded system is a very frequent word we use that. So, how will you define an embedded system? An embedded system is having the required software and hardware in a single chip, and they are specific in nature. The software hardware used for one embedded system cannot be used for another embedded system. The recent Ford car consists 600 embedded system inbuilt for controlling the temperature, controlling the fuel, controlling the operations of the car, everything. So the software and hardware used in one chip cannot be used for another one. So they are having a real-time operating system, not like our uh, uh, normal operating system of Microsoft or Unix like that. They are real-time operating system which will be applicable to the specific software and hardware for the particular VLSI is concerned. So they are power constrained. So each the power should be utilized in a very proper way. So optimal design is required for that. Long-term evolution is the standard which is adopted on 3G and beyond 3G networks. The LTE, LTE-A are working very well with providing higher data rates for wireless communication. And one of the ambitions for the emerging communication is all IP networks should come. Now we have cellular network, PSTN network, ISDN network, data network, IP network, CAT network for different services. Instead, there will be only one network, internet based, because IP Internet Protocol is the official protocol for internet. So if the same protocol used for all the communication, that will be well and good. So it is not a single day endeavor or single month endeavor. It is a very long time consuming process, but it gives wonderful solutions. So all IP based network is one of the aspirations of the communication which is expected to come in the future. So I want to drag the attention of the audience for the slide given in the 51. You can be able to see two curves in this one. Are you able to see? Hello? 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 Sir?
Yes, sir.
You can see two curves here. One is wireless and one is wireline. Always the wireline is better than the wireless. So always in the quality aspect, the wireline communication is better than the wireless communication. So now if you ask, the wireless communication belongs to whom? It is property of whom? It is property of everyone. You can see the news vendor, newspaper vendor. For him, it is not immaterial that whether he is using 3G or 4G, whether it consists OFDM or ASK, FSK, that doesn't matter. He has to understand only two things: green button, red button, to on the mobile and switch off the mobile. That is sufficient. So Gandhi said, yeah, our father of nation, Gandhi once said, there are two technology is one, which is common to everyone in the country, including the richest person and the poorest person. So the wireless communication has achieved that dream. So each and every sector of our country, our world is utilizing it. It is really a great revolution, social wise. And one of the biggest problems of India is to give education to everyone available here, as it has 130 crores of population. So here the problem is teachers are less, where the children are more. So with the tele-education, now I am sitting somewhere in Pondicherry talking to all of you. You are in Chennai. This is possible because of the tele-link. So the same way, teacher may be anywhere. Therefore, the children available in the hill, the children available in the forest, children available in the desert of Rajasthan will be very much benefited by tele-education. So rural connectivity. Every biggest complaint here is only town people get all benefits of the country, rural is always not given priority. So with our wireless communication, excellent rural connectivity we can provide. And telemedicine, the biggest problem is doctor is available somewhere. He may not come to the hill village or forest village or desert village. So with the telemedicine, you can get the advice of the doctor. And in the wireless communication, I am coming to the almost last slide of my presentation. It touches the different areas in which you can do research. Actually, the, the advantage of wireless networks are the networks are more, as I have listed, ADAPT network, sensor network, LTE networks, cognitive radio networks, Bluetooth technology, broadband networks, ubiquitous computing, IoT, Wi-Fi, WiMAX, wireless LAN. So many standards are available. All are new standards. So newer protocols have to be evolved for everyone. Every day newer technology comes. Therefore, it is one of the potential areas to do your research. It is not saturated. It is very much emerging. Therefore, always it has the scope to do your research. So you can develop a newer protocol, newer standard, and you can also do in error control, because in the wireless communication, the biggest problem is error. You send the data. One is you are sending one, it can be understood as zero. You are sending zero, it can be understood as one. Therefore, error frequently occur in the wireless communication. So, suitable error control technologies you can devise in order to reduce error. Power is the biggest problem always, because it is directly connected to the cost. So, suitable power control algorithm you can devise so that a lesser power will be utilized. So lesser economical system will be adopted. Another area of research is call admission control. So the call admission is very important. As I told, always the problem is the demand is more, availability is very less. Therefore, what priority you have to give. So higher priority calls have to be given. So suitable call admission methodologies you can evolve. Resource allocation. So the available spectrum is very, very less. So spectrum is one resource. Equipment is another resource. And time is another resource. By utilizing the proper allocation of the resource will be definitely one of the potential areas. Quality of service. So always we need quality. Now, in communication, especially the voice quality required, picture quality required, video quality required. So to ensure required quality of service, you can adopt suitable methodologies. And scheduling is another area. So time control is very important for each and every one. So scheduling you can provide. So uh, I come to the end of the session. Of course, I will tackle the questions if you have anyone. I want to thank the management of Chennai Institute of Technology for giving me an opportunity to talk in this way. It is looking somewhat different. So without audience, without anybody, I am keep on talking. It is very nice. But this is only the effective way to contact all of you in this pandemic situation. I thank the organization, the institute, Chennai Institute of Technology, which has very long association with me. I have more than 10 years association with the Chennai Institute of Technology. 3 times I have visited. So I thank the chairman and other authorities of the Chennai Institute of Technology. I personally thank Mr. Balamurali, who is my close friend, who contacted me frequently for fixing this one. Because of his request only, because I had some hesitation to taking up this one, this type of lecture, but because of his request only, I have given my consent. So I thank Mr. Balamurali, and of course I thank all the audience who are patiently listening this one. I don't know how much it is useful to you, because in my personal opinion, the direct contact class cannot replace anyone. But anyway, if a technology comes, we have to oblige that. We have to always harvest the advantages of that. So in that aspect, I thank all the participants who are patiently listening my talk for the last 1 hour, and I thank other people, the student who introduced me, the faculty who introduced me, everyone engaged in this wonderful activity. I feel very happy if you take up the questions, because questions will be helpful in two ways. One, you can get it clarified. Another one, the speaker myself will understand that you have listened to my lecture. So I feel extremely happy to take up the questions from all of you. So one by one, please ask.
Thank you, sir. Thank you very much for the detailed explanation about wireless communication. We have still questions, sir. We'll take now. Is there any proven study on effect of radiation on health?
Yes, sir, definitely, definitely. Our Indian government has allowed only a particular radiation, not more than 20 watts from uh, uh, a radiator. Just I will give one example. Say, what is the normal wattage of a tube light? 40 watts. Normal wattage of a fan, 40 watts. Suppose you are radiating a 40-watt radiation from your tower, and under that you are using your mobile from your ears, means direct 40 watts are directly coming to very near to your brain. Brain is a very soft one, very made up of soft tissues. So uh, even you can see, you have the mobile, if some ring comes, it will jump, it will move. So how much energy it has? Suppose you are nearer to the tower, definitely all that energy will come to you. So the it is a very you have asked any proven result. It is a very well-known result, very obvious. There is a proverb in Tamil Nadu, "Kai punnuku kannadi irukku." Like that, it is a very logical one. So definitely, if you radiate high power, definitely it is injurious to all biological system, including the plants, bats, not only the human beings, everyone, all living organisms available, including bacteria, virus.
Thank you, sir. Thank you. What kind of antenna we can select in MIMO wireless communication?
Basically, antenna means it is converting electrical signal to electromagnetic radiation. Basically, it will have a dipole, a radiating element. Radiating element means which will convert electrical signal to electromagnetic radiation. It is common to all antenna, whether the antenna mounted at your phone, or the antenna your mobile consists, the antenna which all Wi-Fi, WiMAX devices are considered. For any type, definitely the radiating element should be there. But in the mobile, we are not able to see them because they are very miniatured in size. Definitely for transmission reception, it will have, it should have the antenna. They are miniature in size. In the coming beyond 4G or 5G, or in the beyond 4G, that is the 5G, people are talking about smart antenna. But whatever it is, an antenna is radiating element. The input to the radiating element is electrical signal. Output is electromagnetic radiation, or vice versa. So that element should be common, whether it is very big in size, very small in size, that is used giving signal, be it a parabolic antenna and or dish antenna, because then only the coverage will be more, it will be more, and the radiation will be more.
Yeah, Sar has to take a seat. He will come back again. Please wait. Yes, Sar will join again. Please wait for 3 minutes. We have afternoon session at 2 o'clock by Deeman Malik, IIT Delhi, powering the Internet of Things, energy harvesting and beyond. Under this topic, he is going to give a lecture on at 2 o'clock. Yeah, Sar joined. Please wait. Yeah, yeah.
This is the biggest problem of wireless communication.
Yes, sir. So I have one more question. Uh, uh, how to improve signal power in low SNR region?
This is once again their trade-off. Only if more radiating power is given, then only coverage will be more. Uh, so in the lower area, only you have to improve the power, but increasing the power will affect the biological system. So it is a trade-off. Depending upon the situation, only we have to find it out. Of course, we have a smaller solution for that. Optimal system we can utilize. There are some devices which will consume very less power. So in that, even with the smaller SNR itself, the system will work very efficiently. So the optimal design systems that can be performed.
Yeah, thank you, sir. Why CDMA is not as popular as TDMA?
There is uh, two answers for that. One is business wise, another is technique wise. Definitely, CDMA is a better technology. No problem. CDMA is a better technology that will work it very well. But what advantage we have in the GSM, the competing technology? It is available already. It is existing technology. So with the existing network, it will suppose you have GSM. It worked in 2G also, 2.5G also, 3G also, 4G also. Definitely beyond 4G also it will work. But in the CDMA, if you want to replace CDMA completely, all GSM has to be completely replaced, which is a very costly affair. Nobody will prefer. With already existing technology, very easily you can incorporate the changes so that the CDMA has not clicked very well in business perspective or the practical. We should not say business perspective. The practical perspective. Suppose I have a television, I want more features. Then, if I pay for software some 4,000 or 5,000, it will be upgraded means This is choice number one. Choice number two, with 1 lakh rupees, I can get a newer TV. Definitely, I will prefer the first one because by spending 5,000, I can get all the features. Already, I have the television. The newer software which you are loading will work very well with the existing one. But if I want a newer one, I have to spend 1 lakh. Nobody will be ready, or 95% of will be opting for the first option only. So that is the practical reason of updating the existing system is possible in the GSI.
Yeah, yes. We can use turbo codes with small SMS.
You are talking about error control codes. Yes, we can use turbo code.
Yes.
Actually, the literature survey says that more than 100 codes are available, 100 error control codes. Block code, linear block code, cyclic code, convolutional code, turbo codes, LTPC codes, Reed-Solomon codes. So many codes are available. Of course, my PhD area is error control only. I know very close association with that. Now, there are two things. One, if you want more quality, then the toughest error control code you have to use. But the toughest error control will provide more quality, but the complexity will become more. For example, as you ask, the turbo code is a very good code. For a wireless channel, Shannon knew the limit. Shannon has given a theorem. What is the capacity of a particular channel is concerned? It is called Shannon theory, Shannon capacity theorem. If you use turbo code, you will get as per Shannon capacity theorem. For every channel, you can touch up the maximum capacity. For example, like if you read this gate, you can get 100 out of 100 like that. If you use the turbo code, definitely highest performance you can get. But the problem is the complexity of the turbo code is very high. It consists of dual convolutional codes, two encoder and two decoder, which will work continuously. So the maintenance will be the problem. The complexity will be the problem. If you are ready to prefer the complexity, definitely turbo code will be a better code.
Yes, sir. One more question is why MIMO mostly used in OFDMA?
So,
Why MIMO mostly used in OFDMA?
MIMO means many input, many output antennas. Instead of one antenna, multiple antennas can be used. When we will use, whenever signal is weak, we will use. There is no strict rule that it is used only for OFDM. You should be only used for the LTE like that. Wherever your reliability is the matter, you can use. You can use for micro. So in the most of the applications of the wireless, the biggest problem is the reliability because as I told, attenuation, absorption, interference, all are coming into the picture. Therefore, instead of working with a single transmitter antenna and single receiver antenna, multiple antenna and multiple receiver antenna will work. So we prefer MIMO, not only OFDM, generally for all wireless communication is concerned.
What is spatial modulation, sir?
Spatial modulation is space-wise we will modulate. For example, you can say it is uh, one type of amplitude modulation. So space means what? The location. So the signal varying from one cycle of signal varying from 0 to 2 pi. So it will have at each and every angle the space is different, amplitude is different. So with respect to the variation of the space, the modulation is carried out. So modulation is the process of changing some characteristics of the carrier signal. We can change either amplitude or frequency or phase. In your spatial modulation, we will change the characteristics with respect to the spatial changes.
Yeah, thank you, sir.
I will be happy if uh, any audience is giving feedback about my lecture. I want to see audience if possible. If we need not be
Um,
positive feedback, it may be negative feedback also. If it is possible, explore. Otherwise, no problem.
Yes, yes, sir. So, like yesterday, you can give request to speak. I will allow you to talk. Anybody is there? Anybody willing to give feedback? Kindly give request to
Have
speak.
you felt for the last 1 hour?
I will allow you to speak. Nitin Kodari, I have allowed you. Nitin Kodari, I allowed you. You can join. You can talk. I think he can't able to talk with us.
Okay, no problem, no problem.
Thank you, sir. Thank you for the informative session, sir, regarding wireless communication. Thank you, participants. If you have any other questions, you can contact sir. Okay. Any other questions? No. Okay. Okay, sir. Thank you very much for your. Thank
Thank
you.
you. So kind of.
We'll meet again on the vacation, sir. Thank you, sir. Thank you. Yeah. Hope today's session was very informative and nice session. Next session will start at 2 p.m. by Deeman Malik, IIT Delhi, powering the IoT, energy harvesting and beyond. That under the topic we're going to talk. So we will meet again at 2 p.m. So I will share the all videos and PPTs to your mail today or tomorrow. Okay. Thank you very much. We'll meet again at 2 p.m. Thank you.